अस्सलाम वालेकुम सर।
ओके, वालेकुम अस्सलाम। बिस्मिल्लाहिर्रहमानिर्रहीम। क्या बात है, खैरियत है? आप थोड़ा लेट हो गए।
जी अल्हम्दुलिल्लाह सर, ठीक ठीक।
कोई सवाल तो नहीं है लास्ट जो हमने पढ़ा था उसके हवाले से?
नहीं सर।
भाई आप पढ़ भी रहे हो या बस ऐसे ही?
नहीं सर, पढ़ रहे हैं, साथ साथ
आप
तैयारी कर रहे हैं।
काफी ज्यादा चीजें हैं जो आपने एक साथ कर ली। आपके लिए ये रेगुलर सेमेस्टर से हैवी हो गया। चलिए स्टार्ट कर लेते हैं। बिस्मिल्लाहिर्रहमानिर्रहीम। ये जो लास्ट टाइम हमने जो डिकोडिंग सर्किट पढ़ा था नैंड गेट के साथ, उसको थोड़ा सा एक दफा रिफ्रेश कर लेते हैं। ये जो माइक्रो प्रोसेसर है, हाँ, ये जो एड्रेस लाइन है ये माइक्रो प्रोसेसर से आ रही है। और अगर आपको याद हो तो जो हमने यहाँ से स्टार्ट किया था, यानी यहाँ से स्टार्ट किया था, ये दिस वाज आवर स्टार्टिंग पॉइंट। जब हमने डिकोडिंग सर्किट को देखना शुरू किया, चिप इनेबल एट एक्टिव लो लॉजिक मींस वी नीड टू हैव ए जीरो हियर सो दैट ये जो एक चिप है, जो आईसी है, ये सेलेक्ट हो जाए। ये आईसी जो है ये मेमोरी है, एक मेमोरी आईसी है। और अगर हम थोड़ा सा इसकी डिटेल पढ़ेंगे तो ये जो है ये इलेक्ट्रिकली प्रोग्रामेबल रीड ओनली मेमोरी है। तो हम रीड ओनली मेमोरी या सिंपल मेमोरी कह लें, ये मेमोरी आईसी है। और नैंड गेट का मतलब ये है कि जब हम नैंड गेट की बात करते हैं थोड़ा सा हमारा कल तो नैंड गेट की आउटपुट पे जीरो का मतलब ये है कि ऑल इनपुट्स आर वन, सो ईच ऑफ द लाइन, every line is at logic level 1, including this line as well. It should also be on the logic level 1. So every line, every every input of the NAND gate should have at logic level 1. So this will ensure that the output of the NAND gate is 0. So this leads us to primarily find out the starting and the end address of this memory in the system. So how to find the address range, memory address range? How to find that? So it is very simple that we start with A19. So A19 pin need logic level 1, first we write logic level 1, then A18 required logic level 1, A17 required logic level 1, A16 required logic level 1. So after 4 ones, we need to add one space here. Then A15 require logic level 1, A14 required logic level 1, A13 required logic level 1, A12 required logic level 1. Then we place a space here. Then A11 required logic level 1. So where are the rest of the pins? The rest of the pins are attached with the IC, with the memory IC. So from A10 to A0. So for A10 to A0, we need to write here zeros. So zeros, then again zeros, and again zeros. So this is our start address for the memory. Similarly, we can find the end address, and in end address, all values are 1. This one should be here in this way. So all values should be 1. So there is a way to write this in a single line, and if we want to write it in a single line, we need to write it like this. That this is a fixed uh, part of the memory address, and then we have a variable part of the memory address. So this way we write this memory address in a single line. And from this single line, we can write it again for zeros. For this x, we know that don't care condition can take 0 or 1 and write 1, 1, 1, 1. And then we convert it into the hexadecimal. This value convert into the hexadecimal of f. Similarly, this converts into the f. And for all zeros, this converted into 8, 0, and 0. And for the other case, when all values are 1, then we have the end address. So this is the case when we are able to write it in hexadecimal. As it can be written in the caption of the figure, the simple NAND gate decoder that selects a 2716 EPROM for memory location. The starting address is FF800 and the ending address is FFFFFF. So this way, this is just a refresher. यानी जो हमने लास्ट टाइम पढ़ा था उसको हमने एक दफा देख लिया. Now let's see कि किताब ने इसको किस तरीके से रिप्रेजेंट किया है. Okay, so this is the example in which the book represented it. As you can see, there is a fixed part of the address. Up till here. Okay, this is the fixed part. Fixed part of the address, and this x, which is don't care condition, is a variable part which can be replaced with all zeros to find the start address and all ones if we are interested to find the end address. So this is the way how you actually write it. और मैं आपको बताया है कि किस तरीके से हम इसको फाइंड करेंगे. एंड डिस्क्रिप्शन द इन टेक्स्ट, तो टेक्स्ट में किताब में ये चीजें लिखी हुई बुक में आपको मिल जाएंगी. मुबशर, इफ देयर इज एनी क्वेश्चन. जी मुबशर, कोई सवाल?
जी सर. नो सर. बेटा
तैयारी कर रहे हैं एग्जाम की?
जी सर, तैयारी चल रही है सर.
Okay, so this will be the last part of this chapter we are doing. Then we will move towards the next chapter. So in this example, as you can see, there is a decoder IC. So we have a decoder IC. And this decoder IC is used to attach a memory bank. Okay, this is a memory bank. Let me write here, this is a memory bank. which consists of a number of memory ICs. Okay. There are 8 ICs starting from 0, let's say 0, 1, this is 0, this is 1, this is 2, this is 3, and similarly 4, 5, 6, and 7. So there are total 8 memories and similar memories, that means identical memories. And all memories have the same 2764 number. And as you can see, the address lines from A0 to A12. And similarly, if you can see on the left side of this decoder, you can find the high order address lines from A30 to A9. So if we write here similar of our pattern, that A90, then we write let's say A2. Similarly, we write A17, then we write A16. So this way, we can primarily write these numbers on our paper. So 15, A14, then A13, then A12. We have had a problem. मुबशर, आपको आवाज आ रही है बेटा?
जी सर, आवाज आ रही है।
यहाँ हमारे कुछ नेटवर्क का इश्यू चल रहा है, सिस्टम डिस्कनेक्ट हो गया था। ओके, सो इट इज बेटर टू राइट ऑन नोटपैड, क्योंकि ये अगर इस तरह का मसला हुआ तो ये एनोटेशंस जो है ये दोबारा गायब हो जाएंगे। ये माउस बहुत तंग कर रहा है आज। ओके, सो वी राइट ए मल्टीपल टाइम्स। ये मेरा पेपर पे करना पड़ेगा। Once we finish writing it, now we have to write the labels from here. Okay, so we starting from the A90, and because there is a requirement of low logic, so we have to primarily write here Based on our earlier experience with the NAND gate, the logic level 0 is required here. And because of the NAND gate, all the inputs has to be 1. So for A19, A18 and A17, we write 1. So we write 1 here, we write 1 here, we write 1. Now for A16, the G1 requirement is logic level 1. So we have to write here 1. So because of this A16 has to be 1. And now we move towards A13, A14 and A15. So these values may vary. So we can have initially 0, 0, 0 values. And then the rest of the values ये चला गया. पता नहीं क्या मसला हो गया इसको. Okay, so this way we just taken the first अच्छे तरीके से हैंडल नहीं कर पा रहे. एनीहाउ, मुबश्शिर आपको आवाज आ रही है बेटा? मुबश्शिर आप?
जी सर अब आ रही है.
ओके, थैंक यू.
जी सर आवाज आ रही है.
This is for the line number 0. Line number 0, we have to set here all zeros. So for line number 0, we have written the same value 3 times. Now we change this to the initial value of 0. So all are zeros. So we can find the range. And similarly, all the values on the lower have to be replaced with 1. And this will generate the address F000 hexadecimal, because these 4 become F, and then there are leading 4 zeros in hexadecimal. Similarly, this will become F1, F1, and then F hexadecimal. So as you can see, it is written on the line number 0, F0000, F1111, F. So this is the address range for the memory bank 0, and then we can find in a similar pattern for memory bank 1 and onwards. Let's find for the memory number 1. For memory number 1, we have to for these 3 pins, A13, A14 and A15, we have to place here 1 here, similarly 1 here, and similarly 1. So this will bring us the range of the memory that is attached to the pin number 1. And we then convert this binary value to a hexadecimal value. We get F20000 hexadecimal, and similarly F3, FF. In a similar pattern, we can find all the addresses. Let us find the 7 number. Okay, when we go to the 7 number, we have to replace with all ones. So in this way, a new start address and a new end address will appear, and that corresponds to the line number 7 for this decoder IC. So this is the way how we can primarily find the memory address and the individual memory address inside this memory bank. किसी एक का भी हम मालूम कर सकते हैं. If this value is not given to us, we can find it. Give question if there is any question.
No, sir.
Okay, so this first session now completes. In the next session, we will review the basic IO interfaces. Okay, but after 10 minutes, we will have another session. Okay, last.
No.